Okay, so we've got here a string of natural length 5/3 meters. Okay, so I've written that there, and the modulus of elasticity of the string, so that's sort of measuring the strength of that string, is 245 newtons. Okay, so it's attached to a fixed point O. The other end of the string is attached to a particle of mass 7.5 kilograms, and it hangs in equilibrium vertically below O. So we want to imagine like that's like the ceiling, and it's attached there to the ceiling, and it's just hanging here, that weight of the end of the string of mass 7.5 kilograms, so the weight would be 7.5 times G, yeah? So in A, it says calculate the extension of the string, okay? Well, what we need to appreciate is that the system is in equilibrium, okay? So we can write that down. The system is in equilibrium. So when we apply Newton's second law, okay, of motion, well, the acceleration is going to be 0, yeah, because it's balanced. So when we apply that, then the resultant force is going to be 0, which means these forces have to balance. Okay, so if the resultant force is 0, these forces balance, so T will have to equal 7.5 G. Okay, now that we know the tension, we can work out the extension of the string, because we know Hooke's law to be lambda x over L. Okay, so lambda is 245, that's the elasticity of the string. X we want to work out, so I'll leave that there. And L is the natural length of the spring, which is 5/3. But of course we know the tension to be 7.5 G. Okay, so you just got to do a little bit of work here to work out X. So 7.5 G, that'll be 7.5 times 9.8. Okay, with gravity there. That 5/3 we can take over the other side and times. That'll equal to 245x. Just do that calculation. And I get on this side 245 over 2, that happens to be, equals 245x there. So 245 will cancel, and I end up with x to be 0.5 meters. That's the extension there. Okay. So in B then, this is determine the elastic energy stored in the string. Okay, so because it's stretched, because the string is stretched, it's now got an energy in there which can be sort of released, okay? So we measure the elastic potential energy, okay, so we call it EPE there, by this formula, lambda x squared over 2L, okay? So that's simply measuring the energy that is stored in the string because it's been stretched. So lambda is 245, x, the extension we just worked out to be 0.5, so we square that, square the extension, and then on the bottom twice times the natural length. So we get that there. So we just got to plug that into our calculator, okay, and we'll get an answer. So when I type it into calculator, I get 18.375, and of course because it's energy we need to write down joules there. Okay.